All right, well, thank you to MICA for having us here today, and we're really honored to be one of the companies selected for this latest round of funding. So H2nanO, our mission is to leverage nature to drive innovative solutions for water treatment and management. And we do this through advances in nanotechnology and materials science. We are a startup company that spun out of some research about 10 years ago at the University of Waterloo. And since then, we've scaled up nearing commercialization levels and developed 3 different technologies that we have in our portfolio for water treatment and management. So the first is our solar pass technology. It uses sunlight to drive an advanced oxidation process, similar to what you would get from like an ozone or peroxide process, but solely using sunlight. The second is an iteration of this process, which is able to treat emissions and hazardous odor compounds from the water prior to being emitted into the atmosphere. And the third and final one is our Oasis technology, which leverages sunlight to accelerate natural evaporation processes. So the first technology, this is more of our mature product, our flagship, I would call it, is the solar pass, solar advanced oxidation. So it's an entirely passive, off-grid technology designed for remote locations where you don't have access to existing grid infrastructure, and it just uses sunlight to produce powerful oxidant chemicals from the water itself. It's a very high-strength oxidant, and it situates at a platform of a floating beads that we have then coated with nanoparticles, which are then able to harness that sunlight, as I mentioned. So when mixed in a solution, they float to the surface and are able to self-distribute on pond in an existing water tank or water body. When exposed to sunlight, the photocatalyst particles are able to produce really powerful mixed radical species that drive chemical oxidation reactions or reduction processes. These have been shown to rapidly degrade organics or other mineral contaminants with just solely sunlight, so you can eliminate the use of hazardous chemical systems. You don't need to handle them on site, and no grid energy is required for this treatment process to occur. So this technology has been applied to a wide variety of different chemicals, lots of literature research on this as well, but within our own portfolio, we've looked at a handful of different recalcitrant organics, stuff that is difficult to treat by conventional technologies and inadequately addressed by other passive treatment technologies. We've also looked at metals and organics removal, more relevant to some of the mineral mining applications, looking at oxidative metals such as manganese and iron, as well as things like cyanide, thiosalts, and ammonia. The principal project we've been funded for under the MICA program is looking at Canada's oil sands. This has been our primary adopter to date, and we're looking at an accelerated passive treatment in order to aid in the detoxification and eventual disposal or reuse of the vast amount of tailings ponds they have on site. These ponds have potentially harmful and toxic compounds situated in it from the bitumen mining operations, and they are quite toxic and unable to be released to the environment. Currently, there are no regulations that support the release of these massive tailing systems, and so they just keep accumulating on site. However, we've shown and demonstrated with our technology that within, oh, we lost it.
Sorry. You're on a roll too.
Oh, thank you. I'll try to get back into it. So we've shown within about 1 to 2 days of sunlight equivalent exposure, we can eliminate that acute toxicity effects just with our sunlight-driven technology. We can also treat these compounds that are potentially hazardous to really dilute levels, able to meet some of the most stringent guidelines that will eventually be put in place. And this is all done, we've scaled this up from the bench scale all the way up to what you will see pictured there was one of our demonstration units from last summer. And this is actually, to the best of our knowledge, the largest deployment of this type of photocatalytic water treatment technology ever in the world. So we are at unprecedented scales of the deployment of this technology, and we're continuing to progress further and hopefully through the MICA funding, take this to the next stage for commercial development. We've also looked at how we can integrate and synergize this chemical treatment technology with existing passive biotreatment. So we had a project last summer as well, where we were investigating how we can leverage some of the solar pass treatment effects and create a perfect system between some biotreatment systems and ours. So we've been looking at various combinations of the two, both one in front of the other, for reducing some of the aquatic toxicity, improving the health of these biotreatment systems, as well as the complementary and synergistic treatment effects where one is able to target metals, one's targeting organics. Both technologies work in synergy together, off-grid, no waste, in a rather harmonious treatment system. Show again. Okay. There we go. So when we are deploying this technology at scale, we've developed two different modes of operating so far. So we have our self-contained modular pond reactors. We can deploy, set up some external containment. The beads can be deployed as a slurry. They naturally spread out across the surface of the water, and they're able to self-distribute themselves, and we can just operate and service as needed, but rather remote operation with minimal operator interference is necessary. And they can be collected and completely removed at the end of their lifetime. We've also been looking at an in-situ pond retrofit for existing tailings applications where we can easily deploy this technology as an existing process and improve it through our treatment technology. The other technology I want to highlight as part of this project is our Oasis enhanced evaporation technology. It uses a similar buoyant floating bead platform. However, instead of coating it with a photocatalytic material for treatment, we've added a photothermal material, which is more efficiently able to harness solar thermal energy to drive and accelerate natural evaporation rates. So we've been looking at deploying this for accelerated dewatering of various tailings pond systems, again, using just natural energy in a more efficient manner, but also on the production side for some brine and solution mining operations where we can accelerate that production naturally, even extend the operating season for some of these evaporative processes. How it works is the beads are all floating at the surface of the water where they are able to more efficiently harness the same amount of solar energy that the pond would typically receive, but concentrate that at the surface where you're actually having that evaporation occur. This minimizes the heat loss to the bulk water and is able to more efficiently drive that evaporation. There are also some secondary effects with improved surface transfer for that water to evaporate and some moisture wicking effects, but it's principally a heat-driven application. Oh, slides got a little bit jumbled there. But what we've seen through the deployment of this technology is we've been able to take what a natural evaporation would be for a pond and accelerate that by about 50 to 110% in some applications. So we can almost double the natural evaporation rate depending on the geographical location and the water chemistry. We've also been able to target some high TDS brines, which typical systems like RO or even mechanical spray evaporators are unable to deal with. And we're able to have an accelerated evaporation process for these types of systems. So with that, I'd like to thank you for your attention and welcome any questions or discussions that come out of this. So, thank you.
Questions, concerns, comments?
Perfect. All right, thank you.